Okay, in this recording we are going to go over measures of relative standing, section 3.5 from our text, specifically talking about percentiles and z-scores. I am using again the Unit 2 course content file that we have. I'm going to be using the VFT data, and we're going to be looking at run times for running the 1.5 miles. We have two fictional people here, Alice and Bob, and these are their run times. We're going to find out how well they did. To do that first, we're going to compute the mean and standard deviation, then think about percentiles, and then we're going to rank their scores two different ways. All right, first to get the mean, we're going to use the average command, and then I'm going to click over here for the run times, and I hit the hold down Control Shift and then hit the down arrow, highlights the whole column for me. I'll hit enter, and the average run time is 672 seconds. I'm, for convenience sake, going to copy this range because I'm going to use it later on. And now I'm going to come here to the standard deviation and enter standard deviation. This is hit tab to get this one and paste in my range. Standard deviation is 106 seconds. The data, I have made a histogram already, is sort of normally distributed, more of a right tail, but sort of normally distributed. So some of our heuristics before about knowing how much data falls within one or two standard deviations from the mean will mostly hold. So now I'm curious about what's the 20th percentile score runtime. What runtime was longer than or higher than 20% of the cadets? So I'm going to use the percentile function, and again, we have an exclusive and inclusive version, and we always want to use the inclusive version. I'm going to paste my array, comma, and then I want the 20th percentile, so I'm going to put in 0.2 for 20th percent, and then hit enter. And so it says this: if you had a runtime of 606 seconds, then that was a runtime that was longer than 20% of the core, which actually in this case, the bigger the number, the slower you are, so you were faster than 80% of the core. All right. 5th percentile is a similar thing, so I'll just type in percentile again, inclusive version. I'll paste my array, and my 5th percentile is 0.05, and I'll hit enter. So this is a runtime that was greater than 5% of the core, and again, since we're talking about runtimes, that means it's slower, so you were faster than 95% of the core. And finally, the 95th percentile, using the inclusive function, I'll paste my array in 0.95, hit enter, and 841 seconds. So if you ran the 1.5 miles in 841 seconds, your runtime was bigger than 95% of the core, which means it was slower than 95% of the core. So not necessarily a great time compared to the other scores that are out there. Now let's think about what that means for Alice and Bob. To find out what her percentile is, what her score's percentile is, we're going to use the percent rank function. Equals percent rank, and again I want the inclusive version. Hit tab, and then I'm going to paste my array, and then comma, and then Excel is prompting me for the X value. What value did she have? And I'm going to click right here. Her value was 560. You could also type in 560, close parentheses, and hit enter. And she had a very good runtime. You'll notice 560 is really close to this 5th percentile right there. So she was faster than 95% of the core. And now let's look at Bob's percentile while we're here thinking about percentiles. I want to equals percent rank, inclusive version. I'll hit tab, paste my range, and then his value is right here. Now hit enter. So his score was greater than 74% of the core. We'll round up, which means he was slower than 74% of the core. So in terms of relative standing, it wasn't fantastic. Now we'll compute z-scores. Z-score says, start with the equal sign. I want to take my value, which is 560. I'm going to subtract from it the mean, which is 672. Close parentheses, then divide by the standard deviation. I'll click on here. I'll hit enter. Alice's z-score is negative, which means it's below average. But in this case, below average is actually a good thing. She was faster than the average score. She is 1 standard deviation from the mean, so not necessarily remarkably or unusually fast, but she is faster than average. And then for Bob's z-score, I'll equals, open parentheses, take his score, subtract from it the mean, and then divide by the standard deviation. And his z-score is 0.35. It is slightly above average, or in terms of run score, slightly slower than average. All right, this covers the basic functions of relative standing, z-scores, and percentiles that we'll be using in section 3.5 of our text.